These are expanding plugs that are controlled by tightening a nut on a bolt. There's two of them. Now, the number for what it is hidden, because it's India, underneath the nut. That one says 1 1/8. Install dry. Do not use sealer. What about lube? So anyway, that says it's 1 1/8 of some dimension. Now let's count the dimensions. This washer, it is a washer. Simple washer. Then there's the cork. Then there's this, I'm going to call it a compressing thing. Anyway, this is a head of a bolt, basically. Now, you can use they'll call them screws or bolts, even though screws and bolts are supposed to be different. The point is that makes it to where you can put it into something and expand it. It needs a thicker material than, you wouldn't want to put into something thin. So this one says it's 1 1/8, and this one says 1 inch if I check it again, which I will do. Yeah. And it says the same thing. It also says mm, but it's blank because they didn't bother stamping the millimeter rating in it. Now, when they say 1 inch and 1 1/4 or 3/4 inch, these are not the actual dimensions in most cases or ever. Now, these are back the way I got them. Obviously, I've messed with them because I bought two of them because I had to mix and match parts. That's what this video is partially about. And also about digital calipers. These are $20 digital calipers. You can find them in all plastic, all metal. It depends on what you're using them for. In this household, there is a all plastic one and then there's the all metal one. They're all good because they do massively better than you can with a tape measure. Please remember, with dimensionless items, you have to actually measure the damn things. And there's no rule or law that says they have to be consistent. The little round washer-looking thing on this end, which actually has a square hole in it rather than a round one, so that it can hang on to the bolt and create a point where you can turn one end of the nut bolt set, and the other one is held back by that square hole and a square shank. This is a lot like a carriage bolt in that way. These dimensions don't have to be any specific dimension. The only dimension it's referring to, proper, would be this rubber gasket. And the whole point of this is it compresses it so it can do multiple diameters. Some of the packaging will tell you all the dimensions. They don't matter. So what you have to do is you have to whip out something to measure it with. Now, you can't really measure this. I've done this and it sucks. Any other way other than having two parallel metal or other materials. Now, this kind of device relies on them being ideally parallel. And then when you look between them, you're not supposed to see a gap that's inconsistent. On metal ones, you don't normally see an inconsistent gap. On this one, now the thing is you'll have a canter or tilt. Now, if I look at the one end, I see that these pinch tighter towards the ends. That's actually not a bad thing, but that just means that you can't measure it reliably all over the length of the supposedly parallel blades. And it's very common for that to be done. And if you grab them at this end and squeeze them, if you can get the thing to hold totally still, which would probably break it, you might see that it changes the shape of it. On the plastic ones, you can actually see that flexation. That's why plastic ones and metal ones, they're going to have different ratios and such. The plastic ones can be made ideally perfect. Okay, now let's get on with this. Start measuring. Both of these have different end bits. Now I'm trying to get one that can plug a 1 inch pipe. 1 inch pipe inner diameter is 1.049 inner diameter. That's a little too small for the outer diameter of 3/4 inch pipe to go into. That's so that you can force fit them, friction fit them, and or weld them or solder them. That was actually the reason I found out. It's an old reasoning board. Anyway, the outer diameter of it is 1.315 inches, or 31% larger or 32% larger than the 1 inch. The other one is 5% larger than an inch. So I'm going to look at these numbers, see if these match, because this one says it's not a 1 inch pipe thing. So let's, first thing we do is we hit our on-off button. It'll be different on every single one of them, and then hit 0, so it's zeroed out for that moment. If the temperature changes or whatever, it's not going to be accurate. Now, in order to supposedly, you're supposed to do this, and that's very difficult, but I'm going to try to do it because it's a thin washer, and I'm going to try to measure it and cry. This is 1.313, so it's just slightly smaller than the ideal size to make this thing come to a complete halt and be perfectly smooth and just slightly undersized. Yeah, for a 1-inch pipe. But it says it's 1 1/8. What about this stuff? Well, let's check our cork. It's 1.13 inches, which means it won't work as the inner diameter of 1.05. And then on the end here, suspiciously, we check it, and it's 0.934 inches, almost exactly 1 inch. Okay, and obviously smaller than the inner diameter of a 1-inch pipe. Now we're going to check our other cork. We check its outer diameter for this to see what kind of pipe it would go into. A 1.2 inch outside. Now that's based on this being completely accurate. This isn't totally accurate. It's off by 3 thousandths. It was tested by me and a friend. So 1 point yada yada means, well, okay, let's check that again. 1.19. Gee, that looks like this 1-inch one would go into a 3/4 inch pipe. What about its diameter of the cork? Let's check that. Cork diameter is almost exactly 1 inch. This one says it's 1 inch. The cork is 1 inch. This one says it's 1 1/8. And its actual diameter is 1.13. Hey, that's suspiciously 1 1/8. So yeah, it's the cork diameter. So what you're doing is you have to find out what the number measurement or the type approved name for it refers to. In this case, it's the cork. Starting point, resting state, unclenched. Next, what can we do with these things that would result in something I'd get flagged for? Well, let's measure the end of this thing. It's 0.81 inches, exactly the size of the ass end of a shotgun shell, or actually the bore of a shotgun shell. Next, the cork on this is 1 inch and can be expanded up to the 1.3, 1.05, whatever, for the pipe. So all I have to do is swap the cork around. Now, the end here, obviously we don't need to worry about the washer. The end here isn't going to work as a breech face in a shotgun. Let's just get to the point. That's where I'm going. So I went out and got these. These are listed as being aluminum. I can get steel, but all I could find was aluminum today. And it's 9/16 inner diameter is the number for it. So that's just a little over 1/2 inch. So let's try it. Now, doing inner diameters is actually harder for me. And it is accurately that number. No, I don't have fractions, but I looked up the number. And it's just slightly the wrong size to fit on there. But it's aluminum. And it is the right size to be the end of the cork. So there we go. Obvious answer. Well, no. You see, this washer here on each of them, the ends of these are identical. You look for the thinnest one. The washer is there to hold the pressure so that it can squeeze this. Aluminum would be a bad choice. But I could take this one that's already with it and put that cork on here so it actually matches. And if I could somehow, I don't know, magically mill it by putting the screw-shaped object into a drill and getting out a metal file, literally a nail file would do it if it's diamond grit, and just spin doctor the thing on the end of a drill and then grind this into a nice beveled edge. And then take my, oh wait a minute, it's got a hex bolt end. Well, we can't do that end, or a square bolt end. What we can do is we can do the same grind on this thing and make it fit. I meant to do that. Make it fit like this so that it would come up flush. And it would work mostly, and it would work for the evil intended purpose of making this into the cork for a slam fire shotgun. Now, why would I make a video about this and not actually, well, is this a bad idea or a good idea? I got asked at a 7-Eleven, there is one, I miss it now because they have pizza right now and I can't get to it. I have to go to the other pizza joint because I'm not in Portland. They asked, how do I do this? And I said I would do a video, look up my channel, and look for the cork and pipe shotgun tutorial. These plugs are used for hundreds of things. I found 2 different hardware stores within a 1/4 mile of here that sell these. One of them is called a 1 inch, and one of them is called a 1 1/8 inch expanding plug, or expanding cork, or expanding bung, or hundreds of different names. Now, why would anybody do this? Oh, by the way, the other one is to get a countersunk hex head that'll fit into this. There is one. It doesn't have the square bolt thing. You're just going to have to use washers and hope it works. And it'll have a hole in it where you put in an Allen wrench and you can stick a BB gun pellet in it or a ball bearing. But anyway, why would anybody want to do this? Like I told that person, knowing is half the battle because you realize there is no battle. Knowing how to make something so you can leave it in a corner that's literally 2 pieces of pipe. One of them is a 1-inch pipe and the other one is the 3/4 inch standard pipe, Schedule 40 or whatever you can get your hands on. And having this cork sealed end and having to only polish out and make larger the inside of the larger pipe, the 1-inch pipe standard, means that you will have the parts for a shotgun sitting there. That means you don't have to actually think about having a shotgun. You can get one for $80. By the way, the pawn shops in town are shutting down. This is Eugene, Oregon. This is hippie central. People are getting shotguns. So anyway, let's move on. Yeah, they literally shut down. You have to do an appointment over the phone. And they don't put up the appointment only sign in the window. Love you guys, but they have a lawnmower there. Anyway, a pawn shop. You can go to Cabela's. But anyway, let's move on. How do we remove the seam in a metal pipe? For a totally unrelated reason. You can sand them, grind them, broach them, blowtorch them, or just buy seamless tubing. Well, seamless tubing is made by drawing it over a mandrel and squeezing it tightly on it. And it squishes the weld in it. When they make the pipe, they start off with a flat piece of material, curve it in, and then run a blowtorch up through the middle and also on the other side as it zips shut towards the weld. And it melts the metal together, it's pressed together. And then they can draw it over a mandrel and squeeze it down, or not even bother with it. It's cheaper. The cheaper stuff does, in fact, still have that seam. The slightly more expensive stuff, they squeeze it down and it presses it mostly flat. It's kind of inconsistent, but it's seamless enough. That's beyond good enough. But drawn over mandrel, contrary to its name, also does a technique called broaching. They make a device that is the exact diameter of the interior, and they put a blade edge on the part where they're going to have a seam and the rest of it's dull. That way it stays centered, reference to the majority of the tubing, and push through. It's welded just like any other tubing. Some of the tubing's sold without doing anything else, but they broach out the weld, then they size it on a mandrel, drawn over mandrel, and broached. The stuff that says seamless is just drawn over mandrel without broaching. None of these standards and wordings mean anything. These idiots don't get anything right. At least that's what I think it is. That means you'd have to go look it up and watch the BBC video of how tubing is made, how it's made. Drawn over mandrel can be cheaper and more uniform on the inner diameter than seamless. Maybe the right dimensions too. They can also, in the process of doing the drawn over mandrel part, do it while it's hot and resize it to exact numbers. Well, when they do the other welding thing, they assume there's slop because there's expansion and contraction because temperatures change every day. A tiny temperature change will cause them to cut the wrong length, and then by the time you get to it, there's going to be a bunch of variation. On the other hand, drawn over mandrel is always done at the same temperature, hot, and pulled down over it. Some of it's cold drawn. But the seamless, because they don't grind off or broach off that seam, can be much more inconsistent. Now, how can you do these things? By the way, I'm including other dimensions below that are very interesting because they line up, like 0.81 inches and 0.886 inches, and yeah. This is the corked video. So anyway, precisely make a bushing that fits inside of the tubing. It can be a hunk of plastic. Make sure the groove in it mirrors the seam by making it soft enough you can just push it through the pipe you have that day and let it grind its own seam. In the process, it'll take part of it out, or raised flashing or weld. Next, make it 4 times longer than the tubing inner diameter when you do it. And cut a space to hold a keyway broach or a hole where a drill bit could go, or a screw and nut and bolt kind of thing, and a busted off piece of something hardened. You can also do hundreds of other methods for it. Or you can just buy it for the 20% extra it costs to buy the tubing the right diameter. And if you can't get it, you can still do that. I might do a video on all of it. I'll have some suggestions below in the written version of it. But one of the best ones is to use a router bit on the end of a drill extendo bar and just pull it through and let it grind it down exactly, just little increments until you get it done. Or do it all in one shot because the router bit can be abrasive and be cantered, so it grabs the edge and grinds it down like that. Thanks for watching. Have a good day. Good luck with that. And yeah, these are $20. You might want one. And it doesn't matter if you want to make a shotgun or just get the right diameter for everything. This speeds things up crazy. because tape measures don't work as well. Bye.